Welcome to another video explaining the universe using the particle model. Today's video is titled Space and Time. But before I get into the subject, I'd like to talk about the videos I have done in general and how I'm going to do videos in the future. I made my first video on August 22nd in 2017. That's almost 4 years ago. And I've made about 150 videos, basically 3 videos every 4 weeks. I intended to do 1 a week. Didn't make it, but nonetheless, I put out quite a few videos explaining the particle model. So I intend from now on to respond to questions or comments as appropriate. Appropriate means if I can give an immediate response in the notification section where you can leave comments and questions. If I can't answer it briefly that way, I will make a video to answer the question. But those will come as they come. And on occasion, I will then make my own when the idea comes around that there's something I should say. I am planning here in the near future to do another experiment. I'll make a video when I have that set up to explain what I'm going to do. And then when it's done, I'll come back and do a video explaining the results. So anyway, things are going to move a little bit differently. I hope you can stay with me, watch the videos as they come up, and keep alert for things happening in the particle model. And you know, we said the book would come out end of last year. Yeah, we keep saying it's close. It's getting closer, so you might want to watch for our book. In general, the last series of videos I've been talking about words. I talked about forces, light. Today it's about space and time. I had a question from a viewer about antennas. I've had one video answering part of his question. I need to talk about vertical antennas and it has to do with resonance. I am having a bit of a time understanding the resonance of an antenna in a real sense, not just mathematical. I also got a question from a viewer who would like to know more about the equations, and I promised I would do a video on that. So those will be upcoming as I get them prepared. But this video is about space and time. This is somewhat more philosophical, and yes, it has some particle model aspects to it. And it also has a lot to do with your opinions, in fact, your belief system about the universe and space and time. And so this is more my opinion. Although Dave and I talk about these things regularly, so I don't expect everyone to agree exactly with what I say, but I thought I'd give you my thoughts on this. I start with a basic assumption, and I've mentioned this before in one of my videos, that the universe contains objects that move. That's my basic assumption, and I'm saying from that statement I can move on to talking about other things, and what you want to talk about is objects and motion. Now, objects occupy space, so that brings in the word space. And interestingly enough, the volume of all the objects is less than the volume of space. Kind of an interesting thought, because some people will believe that the space is infinite. But they'll also think that that mass is infinite. Since it's an infinite universe, there must be infinite mass. But this says no, that the volume of the object must be less than the volume of space. The reason is they have to have room to move. If there's 100% occupancy of objects in the universe, there's no way to move. So that objects occupying space brings in the word space, and of course it takes time for objects to move. Our concept of time is used to measure motion. So let's talk about what an object is. This is, again, my statement. An object is what we can sense or detect. We can, as an example, we can detect atoms, molecules, and larger objects. We can even detect gravity. We feel the pressure of gravity. We can see light. We can feel the force of the magnetic field. And so these are, even though you can't see these things, we can sense them. And that's what I maintain an object is. So now the first question is space an object? Or maybe I should ask it a better question, is empty space an object? Well, whether you agree with it or not, the first statement said that objects occupy space. If empty space is an object, then you have an object occupying an object, which sounds rather contradictory. So I don't tend to think of space, especially empty space, as an object. It's not. I don't think of it as an object. Now you could go to Wikipedia, and Wikipedia doesn't disagree with me much on the point. It states that space is the boundless three-dimensional extent. It's an extent in which objects, they talk about objects, and events have relative position and direction. I didn't talk about position and direction, but yes, you can set up a coordinate system and put the origin at a defined location, and therefore you can talk about an object that's moving, having position, and its motion having direction. Perfectly valid. Physical space. Now they talk about physical space. That sounds like it's an object. You can make an argument about whether I'm saying it's not an object or is. Physical space is often conceived as three linear dimensions, although modern physicists usually consider it with time to be part of a boundless four-dimensional continuum known as space-time. Not going to explain that, but just thought I'd bring in the definition of space from the Wikipedia. Now here's my definition. Space is a three-dimensional volume. Space is a volume. It's not an area. It's not a point. But it's a three-dimensional volume. Objects occupy empty space or move into empty space. This is just a repeat of making it official. Space is an infinite volume in which objects of the universe exist. A little bit more formal. Empty space is a volume with no physical objects. Now, the particle model brings in a different aspect to this issue of empty space. TPM asserts that the universe has an infinite number of levels. This would imply that the sum of all the objects at all levels would occupy 100% of space. There's an infinite number of them, theoretically, an infinite number. And if you include all the levels infinite down to infinity, you have 100% occupancy. Hence, there would be no empty space. But then there would be no movement. You can't, and nothing can move. However, in the particle model, each level is much smaller than the level above it. And most of the lower level particles pass through the higher level objects. In that sense, lower level objects do occupy space. Right now, as I'm sitting here, according to the particle model, I got G1 particles coming through me and G2 particles coming through me. They are at some instant of time, they're occupying my space at the same time I'm occupying that space. So you have these levels of universe. So to kind of point that out, this is our solar system, this is the Earth, and we're on the Earth. And these are objects we can see, and the rest of it generally we think of as open space. Yet there's stuff out there. This picture actually happens to have a bunch of stars in it, and if you think of those stars as G1 particles that are flying through, we think of this space as being open, but because we can't see the G1 particle, doesn't mean it's not there, but it appears like open space. So at our level, which is level 1, we can see all the level 1, and the objects occupy space, and yet there seems to be open space, but at level 2, you have a different picture. This is level 2 open space. These are circles I'm saying are going to represent G1 particles that are moving through space. And now we're the size of the G1 particle. And we can, if we could see everything above us in level 1. But we can't see the G2 particle field, these small ones that are going faster than the speed of light. Looks like at level 2 we have open space, and yet there's stuff out there we can't see. So open space has a different perspective at each level. Is space infinite? This is an interesting drawing showing our ability, how far we could see. Actually, this is stated in a different way, but I'm going to, in 1990, we could see this far, 95 with Hubble, and this is Hubble ultra deep field, and this is Hubble, I'm trying to read it, ultra deep field, something, I can't read it, and this is the future. So our universe keeps getting bigger and bigger. But this line represents kind of the radius of the universe we can see, because we can look up, look down, look back, look forward, look into the paper, into the picture, out of the picture. So this is the radius of our visible universe. The question is, if this is the whole universe, what's this stuff out here? David would answer the question. He says, well, that must be not space out there. Well, what not space is really empty space. And so, yeah, there may be no objects out there if this is all the objects in the universe. But no matter how big you make them, in the future, no matter how big this gets, there's going to be this not space out there, which is really space. Yeah, kind of think that this space is infinite. Now, are objects real? Yeah, if you can sense an object, to me, it's real. That's the reality. I can pick up this pencil, and yeah, I feel it. It's real. You can sense it with your human senses or with instruments. It's real. What I'm really trying to ask here is space real, especially empty space real. That, sounds like no, it shouldn't be real. Well, if you can, let's do a hypothetical that I can, even with the TPM model, get rid of all those lower level stuff, such that there really is nothing in this space. There's nothing there. Not G1, not G2, not G3, all the way down. There's just totally empty space. And then I got objects all around this unique empty space. if an object could move into that space, sounds like space is that's real. That's a real space. Yeah, empty objects are real. Empty space to me is also real. Uh, it, it's kind of a very confusing, but it's very philosophical. And again, you may disagree with these comments, but my opinion, empty space is real. Time is motion. This is a statement made by Dr. Glenn Borkert in his definition of time. Sorry, but in this case, I have a slight disagreement with him. I get his point, but let me go through some reasoning. Does nature know about motion? Well, nature doesn't know about anything, so that's an obvious answer to the question is no, nature doesn't know it's moving. Comet that is flying through space doesn't know how fast it's going. It doesn't know what it's made of. It doesn't know whether it has a comet's tail or not. It doesn't know what color it is. It doesn't know anything. Nature doesn't know. The comets don't know about itself. If it doesn't know about motion, does nature know about time? No, I don't think nature knows about time. Nature doesn't know about anything. And here's the point. It takes intelligent life to sense motion. Intelligent life, humans in particular, maybe there were aliens before us or not. Whatever intelligent life came in when it came into being. In our case, we see the sun rising and setting, and we call it a day, and that's an interval of time. And we break the day up into 24 hours, and then minutes, then seconds. And we humans set this whole idea up. Nature doesn't know about day, hours, minutes, and seconds. It's intelligent life that wants to measure motion. Light moves, and we want to know how fast. You want to know, baby, how long is this stupid lecture talk going to go on? We want to know when we were born and when the next eclipse is going to be. These are all time-related issues. It's intelligent life is the thing that brings time into play. Therefore, my conclusion is time is not infinite. Time is limited to the existence of intelligent life. Guess I answered that question. If the universe has, this is a little more, a different way of saying this, if the universe had a beginning, then before that there was no motion. And time is not possible, therefore time is not infinite. So it depends on what you believe. If you believe the universe has been here forever, always, then yeah, time is infinite. But if you think the universe started at some point, Big Bang, or maybe you're a creationist and you think it started then there was a point in time when there was no motion. And if there's no motion, there's no intelligent being, there's no time. Time may be infinite or not, but since motion is detected by human beings, intelligent beings, then as we understand time, as I understand it, time is not infinite. Time goes backwards. My son Dave asked, can objects like a comet move backwards? No, Halley's comet comes by this way and then later on it comes back the other way. It's going a direction, but it never stops and goes backwards. Trees can't grow backwards. Apples can't jump up on the tree and reconnect and then be swallowed in by the tree. Nature moves always in a forward direction. So the timed events always move forward. Even our measurement of time, for example, for the year. At New Year's, we will add 1 year. Today is the 12th of June, and tomorrow will be the 13th. We add, it always increases, it doesn't decrease. So as a summary, my definition, space is an infinite volume in which objects of the universe exist. Space is a volume. Time is a man-made concept for measuring motion. Those are simple statements of what time and space are. As a conclusion, however, let's just go through and I'm going to answer the questions right off the bat. Is space an object? No. That's by my own definition, though. Not, you could have a different definition. Is space infinite? Yes. Is space real? Yes. Does nature know about motion? No. Does nature know about time? No. Can time go backwards? No. Is motion infinite? Okay. Philosophically, it depends on what you understand about the universe, and you could answer it either way. You can answer that it is infinite because you understand the universe to exist forever. Therefore, motion is infinite, and at the same time, time is would appear to be infinite. But since time is detected, since motion is detected by intelligent being, I contend that time is not infinite, even though motion can be. My name is Bob D. Hilster, and I am your particle model guru. If you have a question, ask Particle. You can do that by emailing me at particleguru@gmail.com, or you can, on the website, click on the little bell. There's a bell there. You click on that. You can leave a comment or a question, and I will try to respond. Thank you for your attention.